So the first box I'm going to walk through in this series is called Bashed, and this is an old retired box on Hack the Box. That means it's not available to those who have the normal subscription or the default subscription because that only gives you active boxes. So because I have the VIP Plus, I think, I can go through some of the old retired boxes. A helpful tip is with these old retired boxes, they're retired, which means people are allowed to post write-ups on them. So any of the boxes you're currently working on that eventually do get retired, it's a good idea to look up write-ups on those on how other people solve them, because commonly there's multiple ways to get to the same end goal or the same flags at the end. And so by looking at other people's write-ups, you can kind of see what they did and maybe learn some new things, or see if there's maybe some different kind of thought processes you can do on future boxes. So we're going to go ahead and start with this box. Let's see, is it being a bit finicky? So I already had it running. Okay, so we've got a retired box here. I'm going to go ahead and spawn it. I did a previous video on VPN connections and how to connect to the lab and that kind of stuff, so I'm not going to spend any time on that. I'm just going to go ahead and start this one up. While that is starting up, we're going to switch over to our Kali Linux, which I have in VMware. In my case, you could also have it in VirtualBox, that works. And I'm going to go ahead and start my VPN connection. And actually, I'll make this full screen. View. There we go, full screen. Okay, that should help. I'm going to go ahead and start my VPN connection, which I already have on my desktop here. So I'm going to do sudo open VPN. So sudo means run as root. In this case, sudo open VPN lab. It's going to I already put in my password previously, so it's not going to ask me for my password, but normally it'll ask you for your Kali password. And you can see we get initialization sequence completed, and then I've got my tunnel IP address up here in the top right. So that's great. Another tip I've noticed is I use VPN connections like NordVPN and that kind of stuff. I've noticed that if you have NordVPN turned on, or another VPN provider, and try to do this hack the box VPN, you might get in a state where it looks like this, but you still can't get to some parts of the box. So just another suggestion is, before you start any hack the box, turn off any other VPNs you have, so that this is the only VPN you have running. Okay, going back to our hack the box, it looks like we have bashed has resolved to a 10 dot whatever IP address, so now it's stood up and we can start looking at it. Going to set up our Kali here. One program I like to use is Terminator. So if you don't have it installed already, I think it's just apt install Terminator. Whoops, let me go ahead and become root with sudo su. Okay, root apt install Terminator. I already have it installed, so it's actually not going to install it, but that's normally how you would install it here. I'm then going to run Terminator. Okay, this is Terminator. The one really nice thing about Terminator is you can basically split out this one view into multiple split views. The reason that's nice is, let's say I'm in my normal terminal over here and I want to I have a couple different threads going. Maybe I have an nmap scan going, I've got like a directory brute forcing going, and I've got some other stuff going on. I would have to open a new tab each time, or a new terminal window, and it gets really annoying having to click through all these tabs. So with Terminator, let's see if I have the default. Oh, I already have it set up. Okay, I'll show how to set it up still. But with Terminator, I can make this full screen, and then I can right click, and you see there's split horizontal and split vertical. So I can split it vertical, and then I can come over here and split this horizontal. And now I have 3 terminals to work with at once, and I don't have to click through all the tabs. So if you want to use Terminator, you can get kind of your preferred preferences set up like this, and then you can right click, go into preferences, go to layouts, add a layout. We'll call this our bashed layout. Close. And now let's close these terminals. If I open Terminator again, and maybe I want to jump right into the layout I had before, if you right click and go to layouts, your new layout's right there. You just click it, and now it's all set up for you. Okay. And And we can do this in multiple windows, and this makes it really easy to have multiple terminals open without the overhead of having to click through a bunch of tabs. So looking at our machine over here, the first thing we're always going to want to do is an nmap, right? Because we know what our target IP is we want to test, but we really have no insight into what ports are even open on that machine, right? Because there could be a web port, there might not be a web port, maybe they have SSH, maybe they don't have SSH, there could be SMB, or they couldn't have SMB. We don't really have any insight into what ports are open. So I'm going to go ahead and run an nmap scan in the top right here. In terms of running an nmap scan, we're just going to scan TCP ports to begin with. I'm already root in all of these windows, which is really nice that you'll notice, so I don't have to type sudo a bunch. So I'll do nmap, and then we'll put in our IP address we want to scan. I'm going to do -p or -p-. This means scan all ports. I'm going to do -a, which means I always think of it as standing for all. I think this means do OS discovery and some other stuff. We can always check though using man in Linux, right? Because man is the manual command. So we do man nmap. And then you can do /, and then the flag you're looking for, so -a. And then you can click N to cycle through them, just like you would do a Control F on any other man page. And eventually, should show us here. Here we go. It stands for aggressive scan option. So this option enables OS detection, version scanning, script scanning, and tracer route. So it does all this stuff with the -a flag. So that's a handy flag to remember. The other thing I'm going to do is, because this is a stable connection and I want the scan to go a bit quicker, I'm going to do -t5. This is something else we can look at in the man page. So if I do /-t, okay, I'm at the end of the page, so I'm going to hold Shift N instead of just N, and that will go up. I think I just saw it. Yeah. So you can see -t here, and then you can choose 0 through 5. And 0 is usually, starting at 0, you're kind of doing slower scans, you're more careful, you're not trying to flood the target. And then as you increase the number, you're not as worried about being kind of careful around the IP, and you're just you're trying to be quick and throw a lot of traffic at it at once. Or sorry, I misspoke there. Insane, I think, is basically you're sending traffic to it, but you are spending less time kind of waiting for responses. And if you want to dig into more of like what these T flags mean, if you look it up, nmap, T flags, timing templates. So on the nmap page, they have this helpful table. So you can see with like T0, they do 10 retries, whereas with T5, they only do 2 retries for a given port. And on T0, they spend like 5 minutes for a maximum delay, whereas T5, they spend 5 milliseconds. So T5 is much more quicker. It's not waiting around as longer. And T5 is generally, or higher number timing templates are usually better for more stable connections. When you know that if you don't get a response right away, then that definitely means the port's not open. And because Hack the Box, we have our VPN set up and we're in a stable environment in there, we can go ahead and afford to do a higher timing template. If you're on a normal pen test or an assessment, then you probably wouldn't want to do these lower timing templates. I think Nmap does T2 by default, but it probably says somewhere in here. But the idea is, because if you're doing an assessment or something, you might not know if the network is as stable, so you might need some longer delays to positively identify if a port is open or not. But in our case, we're just going to use T5. So going back to nmap, I think that's all the flags. Let's go ahead and, actually I'm going to go ahead and make a folder for this. Bashed, cd bashed, nmap. And I want to write this output to a file. So I'm going to do the -OA flag. Again, you can just look in the man page /-OA There you go. Output to all formats. It's just going to write a bunch of output files to the nmap file format, the XML file format, and the gnmap. So -o, we'll call this bashed nmap, and that should be all we need. Okay, so our nmap is starting. While nmap is running, with these hack-the-box machines, it's, again, we don't know what ports are open, but it's probably a good guess that there's some common ports that are open. So we could probably guess that maybe port 80 is open, maybe port 2020 or 22 is open. So basically we can kind of guess that there's probably a website that's open. So I'm going to go ahead and switch to a new window up here while my nmap scan is running over here. I'm going to open burp, which is the community edition, which is on all Kali instances by default here. Okay, temporary project started. Newer versions of burp have this really handy feature where if you go into the proxy and you click open browser here, it will just open a Chrome browser for you. And that way you don't have to worry about uploading certificate authorities and all that kind of stuff like you had to do in older versions of burp, if anyone's familiar with that. But for now, we can just go ahead and start trying to navigate to our website or any other websites, and it should pop up in burp. So again, we don't know what ports are open, but while nmap is running, let's make some educated guesses. So assuming a web port is open, that's usually on port 80. So let's just try to go to the IP address just to see if anything happens. So if I put in my IP address and I just run it, you'll see that a web page pops up right away. Okay, so we know port 80 is open, and again, because this is going through burp, if we go to our target tab and we expand this tree, you can see it's already proxying a bunch of stuff and already building out our site for us. So while the nmap scan is running, let's look at this website. So PHP bash, it helps a lot with pen testing. I've tested it on multiple different servers and it was very useful. I actually developed it on this exact server. So if we click into this article, single.html, PHP bash helps a lot with pen testing. I've tested it on multiple different servers and it was very useful. I actually developed it on this exact server. Okay, this is really interesting because one of our goals with websites is if you think about the server, this website is running on a server, right? Our IP address is .71. That's our IP address kind of in this private network. The IP address we're attacking is .176, and .176 has this website open. So, or .176, or sorry, .76 has this website running on it. So when we're interacting with this website and clicking buttons and navigating throughout it, we're interacting with HTTP traffic. If I refresh this page, here's our proxy here, right? If I refresh this page, it makes an HTTP request to single.html and then it returns the HTML. So we're working in HTTP requests right now. But because this website is running on the server, if we can effectively break out of this website or essentially pivot from communicating with this website to communicating with the actual server itself, we could actually start executing commands on the server itself. And you never really want to have that in a server. Because the idea is if you're hosting a website, you really want someone just to interact with that website. You don't want them to kind of break out of that website and start executing commands on the server, right? It's like if I was hosting a website on my IP address and then I broke out of that website and I started executing like ls commands, pwd commands. Whoops. So if I started executing, right, if I started executing commands like this on a server, and this server was supposed to be running a website, and the customer was only supposed to be on the website, or the pen tester customer, whoever was only supposed to be on the website, this would be a big red flag, right? You don't want the end user to actually be executing these system commands on your system. Because as you can imagine, there's a lot of potential exploitation that can happen there because I'm no longer constrained to the website. I can now try privilege escalation. I can read files on the server itself that might not normally be served by the website. And so with this website, if we read this description is saying PHP bash helps you essentially run, it looks like it helps you run system commands. Can I zoom in here? This helps you run like system commands through the website. And we can look at this GitHub repo a bit more if we go back to our Chrome here. Yeah, so if we go to that GitHub, we'll see that this is a GitHub repo, and here's the screenshots. So you can see here that you're on a website right now, but it's letting you, this kind of code package or this thing you can add to your website allows you to execute system commands on the server itself running the website. So if we can get access to this, then we can stop worrying about the website essentially and start executing commands on the server itself, which will give us a lot more avenues of potential exploitation. So the one thing we don't have though is where this PHP bash shell is, right? So if we kind of look at these screenshots, we'll see that they are giving us /upload/phpbash.php. And if I go back to my website over here, we can maybe try that file path or some of these other file paths. So let's try /uploads. Okay, we can see that actually just returns a 200 OK, so far so good. And then let's do phpbash.php like they have in there. Oh, that gives us a 404. Right, 404 not found. So when I was originally solving this box, I tried some other file paths. So maybe you could try uploads php bash. Maybe instead of the uploads folders, it's just phpbash.php. So you try a couple of these and they don't seem to work. Yeah, those are all the file paths I have from here. So the next step is essentially to do directory brute forcing. Before we get into that, let's kind of check our nmap scan because that's probably finished here. So looking at our nmap scan, it looks like just port 80 is open with the website we're looking at. So there's no other ports we really have to look at. Interestingly, port 22 is not open, which means we will not be able to SSH into this server probably. So we're going to be working with reverse shells quite a bit. But port 80 is just open. We're already looking at port 80, so this really doesn't give us a whole ton more insight. So let's go back to the PHP bash shell. And we'll switch over to this one. Okay, so we're guessing that this PHP bash shell probably exists somewhere on the server, but we don't know exactly where. So this is a good point to use directory brute forcing. And you've learned about directory brute forcing, and that's basically where, kind of like we were seeing here, where you try different file paths. So if I go to abc.txt, right, I'm going to get a 404 back. And if I go to cde.txt, I'm going to get another 404 back. If I go to uploads, I'll get a 200 back. So if we use an automated tool to basically do what I just did here, we can submit a giant word list of different possible file names, and it will enumerate through all those and tell us which ones return a 200 response or exist, and which ones will return a 404 response or don't exist. There's a couple tools you can use to do that. There's derb is one popular one. GoBuster, which I don't think I have installed here, but you can install it, it looks like. And then Feroxbuster. So I tend to like to use Feroxbuster. That's what I've been using recently. That sends a lot of traffic really fast, so sometimes it overwhelms the website, and I'll fall back to derb. But for now, I'll go ahead and just do Feroxbuster. So we're going to submit a bunch of file names for this website and see which ones return a 200, and hopefully we can find our PHP bash. So Feroxbuster, yeah, Feroxbuster. If you run the help flag usually, or -h or --help on a lot of these system commands, usually it'll give you a nice little menu telling you what all the flags do. In my case, I'm going to run, here's some examples here at the bottom. I'm going to run Feroxbuster -u for my URL. I'm going to take the URL from here. Then I'm going to do my word list, which is, here we go, -W for word list. So -W. I'm going to use user, share, word list. We can do the derb one. Derb comes with a built-in word list. So we'll go ahead and just use that one first, big.text. And then I'm going to go ahead and add this flag called silent, which I found when I was first going through this box. And silent is really nice because it only prints the URLs that it finds and it turns off logging. Where if you leave logging on, sometimes the tool seems to kind of be a bit buggy and print a bunch of output to your screen that's not necessarily useful. So I'm going to go ahead and do the silent flag, and I'm going to run that. That looks good. Okay, so it starts going through all the words in big.text. So for example, it tells me that HT access is apparently up, which is interesting. So if I go to, because I think it's also reporting 403s. Yeah, so if I go to .ht access, it returns a 403, and that's why Froxbuster returned it. You can also probably filter this to only return 200 responses. In this case, I'm doing 403. Because of this website, it's going to return a few specific paths that will technically return status codes that seem relevant but aren't necessarily. So I'll go ahead and stop the tool here. And we'll come back to this just to show you what this looks like without the silent flag. So if I remove that silent flag and run it, it gives you kind of a more verbose logging. So see, you can see it's a 403. You can see this is a 200. And this is super nice to use, but yeah, you can see it already starts kind of adding a bunch of extra lines and making it hard to read. So I just added -silent flag. So looking through the files that it did find, and maybe it found it down here as well. Yeah, so it found it down here before it started airing out, kind of bugging out here. But if we look up here, we went to like .ht access, and that returned a 403. And then we can see that it found some folders. So there's a CSS folder. That makes sense. A lot of websites will probably have a CSS folder, right? If I go to CSS, I get some directory listing. This might seem super potentially vulnerable because it's directory listing, but this is just CSS files. CSS files just help with the markup of the website, so there's nothing really super relevant in here. And then we have like fonts, images, JS. Those are some other common folders. We have a PHP folder. That's kind of interesting. So if I go to PHP, you can see we get a sendmail.php. If we go to sendmail, we don't actually get to see the source code of the PHP file because it's being resolved. Or it's essentially server-side code, so we don't get to see the actual code of the source file, so it just appears as a blank page to us. If we do eventually get, or we are able to eventually execute system commands, then we can actually read what's in the sendmail.php file, but just from the website perspective, we don't get to see the source code itself because the PHP code is executing server-side. We have an uploads folder. And we already saw that just returns a 200. We have this folder called dev. That's super interesting, right? Why would you have a dev folder? If we go to dev, boom, we get php bash.php and php bash.min.php. If we go back to the GitHub repo, those are the files that essentially we're looking for here. So if I click on php bash.php, it gives us our kind of system terminal like we saw. Let's see. Like we saw on the home page here. And I could type in, can I zoom in on this? Yes, okay. I can type in, who am I? I'm www.data, ID, right? So we are now effectively executing system commands on the server. Like we're going through a website, but we're actually executing system commands on the server. We're basically doing the equivalent of who am I, ID, like this, but we're doing it on the server that's hosting the website itself. Before I progress, I'm going to pause for a second and kind of dive into this directory brute forcing a bit more. If you don't want to hear about that, feel free to jump forward a couple minutes or a minute or two, but I'll digress into this just for a second. So if most of these directory brute forcing tools, if you're not aware, usually have some type of flag called proxy. And so what you can do is you can run the brute forcing tool, or actually not even directory brute forcing, a lot of these command line tools have a flag called proxy. And you can specify the proxy to be your burp suite port, or your port that you're running burp suite on. So you can see the HTTP traffic that the tool is sending. And that helps in debugging some things and kind of gives you some visibility into what the tool is doing. So if we do Feroxbuster, let's see, Feroxbuster. Let me see if, I think that one does have a flag. Yeah, so dash proxy. So if we run the exact same Feroxbuster command, but we do dash dash proxy, and I do HTTP 127.0.0.1, 8080, where am I getting this value? 127.0.0.0.1 is our localhost, that's our machine, and the burp proxy by default, and you can see this by going into the proxy settings here, runs on port 8080. So we're basically telling the tool, hey, when you send out your traffic, send it to localhost port 8080 first, which is our burp, and so it'll pop up in our history log here. So if I run, oh, let me do silent too. So if I run that, you can actually see in our burp instance, see all this HTTP traffic happening. So this is what's all happening in the background. So you can see it tried admin X, got a 404, tried athletes, got a 404, tried bananas, got a 404, and it's trying all these different file paths. And then when it gets a 200 response, it's going to report it to us over here. Right, so these returned, or not 200, anything other than a 404 is how it's set up right now, I think. Yeah, so anything that's not a 404, it'll return. But this is super helpful, right? If you're running a command line tool and maybe you want to work with the HTTP request directly, or you want to see exactly what the tool is doing, you can usually use some type of flag like proxy, or sometimes it might have a slightly different name, but you can do proxy and then your local burp instance, and then it will pop up in burp. Okay, now that we're done with that aside, let's go back to our bash shell here. So we can see that we are the www-data user. We could cat etc password. We can see etc password. etc password is nice because it'll tell you what users exist on the system. So this is kind of their home folders here. So we can see there's a user called AR or RXL and script manager. And we're the www-data user. If we type ls, we have our PHP bash files here. So you can actually see we're at phpbash.php right now, and it's resolving that code server side because we're calling it through the website. Now that we actually we can execute system commands, we can actually print out the source code itself of phpbash.php. Yeah, but you can see, and this is kind of what I found my first run through this box, is that the PHP bash shell tends to have some problems in terms of running some certain commands. And so I kind of want more of a stable shell than what I'm given here by default. So what I'm going to do is I'm going to go ahead and make my own reverse shell using the ability to execute system commands here, and that'll give me a bit more interactivity. Because I'm going to want to execute commands, so sudo-l will work, but there's some other commands, like if I try, let me just check real quick. Sudo. Okay, so that does work. I'll explain this in a second. I'm going to go ahead and set up a reverse shell though. Again, I did find that trying to go through PHP bash for some of the commands I tried to run did kind of run into some errors, and it's always a good exercise to kind of set up a reverse shell and kind of set up your own reverse shell so that you can become used to doing that. So to set up a reverse shell, there's a couple ways you can do that. The first kind of component is you're going to need a listener. You can set up a listener one of several ways. I'm going to do the basic default netcat listener. So I'm going to clear this. I'm going to run a netcat listener. But you could also set up a listener in Metasploit if you wanted to. And there's some other ways to set up listeners. But I'm going to start with the most basic ones for the first couple videos, then I'll probably switch to Metasploit further down the line just because that's easier. So I'm going to use netcat, which is NC. I'm going to do -L for listen, V for verbose, and P for the port. And then I'm going to specify the port as 8989. Okay, so on my machine, I have now opened up port 8989, and it's just listening. It's open on my computer. It's listening for any incoming connections. So this is on my computer, my .71 IP address. On the server, the vulnerable server that's running the website, I am going to execute a command to reach out to my 8989 port and essentially establish a reverse shell. I probably am not going to dive into how exactly the reverse shell works. There's a lot of documentation on how that works. I mean, let's ask ChatGPT. Explain to me how a reverse shell works. Yeah, so you can ask ChatGPT, read through this stuff, read some documentation on it. But basically, I set up a listener on my local host. It's listening for any incoming connections. And then I reach out from the vulnerable web server to my listener. And in doing so, set up a reverse shell that allows me to then execute commands on the web server. To set up a reverse shell, we're going to go ahead and look up some reverse shell payloads. There's a couple ways you can do a reverse shell. The end goal is you need the victim IP or the IP that's running the web server that we have system commands on to reach out to our listener. And so you could either do that through default bash, you could maybe use Python or some other programming language to essentially reach out and establish that connection for us. So I usually do Swiski repo rev shell. And so this GitHub repo has a bunch of different reverse shells you can use. Eventually you'll probably start using one, like it seems like a lot of reverse shells, but once you find the couple that are pretty reliable, those are the ones you tend to use, I find, most of the time. So we can try with the bash one first. So looking at the reverse shell again, it's the IP address that is running the web server that we have system commands on. We're having that reach out to our listener, which means this IP address has to be our personal IP address or our IP address through the VPN connection. And then this port is the port we set up that's listening. So let's copy this. Let's come over here, paste this in. We set this up as 8989, 8989. And then 10.10.14.71. Okay. And if we run this, and I got this IP address because remember this is just our IP address we got from the VPN connection at the very beginning. And you can find it again if you don't remember by just running ifconfig. It's that IP address under the tunnel interface there. So if I run this, did that work? Nope. So it looks like that one didn't work or it didn't reach out to our port here. The one I tend to use a lot of the time is Python. So you can see we've got some reverse shells here where basically you run the Python command and the -C means you can run an inline command. So with Python here, I could do, if I run Python by itself, for example, it'll open a little interactive shell. Then I can do like import OS, import OS, or whatever I want to run. But if you do Python and then add this -C flag, and maybe do print 1, it'll run that Python command without actually going into the interactive shell. So you can run all the Python code in one command and you don't need any interactive stuff. So going back to reverse shell over here, they're basically running a Python command to import a bunch of libraries and then opening up a connection to our personal IP address and our port that we have listening within our VPN connection. and then they're spawning a bin sh shell at the end, which is how we're getting the reverse shell element. So copy all this. Again, this relies on Python, right? So it's totally possible that this victim IP address, or this IP address that we're executing system commands on, doesn't have Python. So that's kind of the first check I'm going to do. So I'm going to do which Python. Excuse me. The which command will return where that binary file is on the server. So this tells us that yes, Python is installed on the server. Sometimes it's not Python and it's Python 3. So you have to do like which Python 3. So this also has Python 3. Usually this Python is Python 2 by default, and then Python 3 is per the name Python 3. So it looks like we can use either one, but sometimes you might not have this first one and you just have to change the Python to Python 3. Which just involves changing the first word in the payload. So let's copy this. Going off the page a bit, but we still need to change. So we're going to change this to where we go, our IP address, and we're going to change this to 898989. Okay. If we run that, okay, now if we come back to our listener, we'll see that the Python code ran, and the Python code itself reached out to our IP address, and then it ran bin sh at the end. And now, if I run id, who am I, and just to make sure I'm typing commands on the IP that's running the website, if I do ifconfig, right, because we can run ifconfig locally to see our local IP addresses, and you can also run ifconfig on whichever server you have access to. If I run ifconfig, we can see this is the 251.76 IP address, which is where the website's running. So we have this reverse shell, which is super nice. It's stable. We don't have to go through a website or PHP or anything like that. It's just bin sh. The next thing we're going to want to do is kind of provide it some more. There's certain commands in this default shell that you run into problems where you try to run the commands and they require a bit of an interactive component. So I think a common one is like if I do, no, that works. I don't have a great example now. I think MySQL is one, but you basically have this default bash shell, but if you try to run some commands, it'll want some interactive components. It might want you to provide some data or kind of want a back and forth between you and the command. So the default shell might not be able to handle that. So what you need to use is a TT, it's called a TTY shell. I usually don't think about it too hard. It's usually a couple commands you just have to put in. In terms of how to tell, am I in a TTY shell or not, I went ahead and just asked ChatGPT, so you can see it gives you some examples. So for example, it's saying if term is, check the value of term. If you're in a TTY shell, it's usually set to something. So if I go back to here and I do environment, grep, term. Oh, it looks like it isn't there, but these steps don't seem too reliable, so I might not actually trust this output a whole ton. But it doesn't hurt just to run the command to get in a TTY shell because, you know, what's the worst that can happen? at the end of the day, you'll just end up with a TTY shell. So usually I just Google TTY shell example. One of the first links comes up. Usually this is the one I tend to always just run, this Python. Again, we know Python exists on the server. If we only had Python 3, we might need to change this from Python to Python 3. So jumping back to my server, I'm just going to go ahead and run that Python command. Okay, and then usually just for just being able to read the bash output and make a more friendly command line to work with, I'll run bash-i. And it'll give me like the nice path and stuff. You're still missing some stuff in this basic reverse shell. Like usually you can click the up arrow to get past history commands, but it doesn't really work here. You see it kind of just prints out some meta characters. Again, there's ways to probably get a better reverse shell, and you can use Metasploit and all that kind of stuff. But for now, I'm just going to do this basic reverse shell. So Going to, so we're in the var www.html dev folder. We can see there's our PHP min, PHP bash, that kind of stuff. I'm going to go ahead and split this so it's more in the center of the page. There we go. So we can see those are our files. You can do ls, these flags, LART. Those are the flags I tend to use in all of my ls commands. It tells you like who owns it, who can access it, all that kind of stuff. If we go up a directory, here's what we were seeing before, right? We've got dev, we've got uploads. These are all our PHP files. So interestingly, there's a file here called config.php. So if I cat config.php, right, this doesn't really give us a whole ton, but if we try to open config.php like normal, we would just get a blank page back, right? Because it's resolving the code like server side, you can think of it, before you see it in the web browser. But now that we're actually executing system commands, you can just cat config.php and see the PHP file. Going up some more, we got HTML. Okay, the next folder I usually jump to right away is the home folder because that has all the users. And usually in these Hack the Box challenges or pretty much any server, you're most interested in this home folder because this will tell you the servers that actually exist on the server that you could try to become or leverage. So let's go ahead and go into the RxL user. Okay, so we have user.text. So I can go ahead cat user.text. There's our flag. We would take this flag and we would go ahead and submit it to Hack the Box. You can see I've actually already done that for the user flag. So, but you would get this little kind of green highlight once you submit it. And you submit it through this submit flag button right here. So or if it'll actually just let me submit it again. Right, submit. Yeah, already owned. Okay, but normally you would get a little congratulations message and this would be filled out. Okay, so that kind of ends the process for getting user. And for this last half of this video, now we're going to focus on privilege escalation and how to actually get to root. Okay, before I move on to the privilege escalation, one quick mention, why can I read this user.txt file in the RxL folder, even though I'm not the RxL user, right? Like if we do ID, we're www-data user. So why can I read this file? This goes into file permissions in Linux, which I'm not going to spend a ton of time on because you should have kind of covered those in other lessons or through the try hack me exercises. But if we do ls lart user.text, remember that kind of each of these chunks pertains to a different stakeholder in the file. So the first 3 letters here are for the owner, which is RxL, and then the second 3 characters here are for the group, which is the RxL group. So RxL is the owner, and the RxL group. Part of the RxL group, then you can access this file, and then these last 3 letters here are for others, which means basically any other user on the system. And so because there's this R flag here, this is saying that any other user on the system can read user.text. You don't need to be the RxL user. It can be any user. So that's why we can read user.text. Okay, from here it kind of depends on what you want to do for privilege escalation. One of the things I like to do is establish persistence. So this is great to have a reverse shell, but it would be super nice if we had an SSH shell or just a normal SSH connection, because then we would have a lot of features like clicking the up arrow to get to the history. The shell would be more stable. It'd be easier to reconnect. There's a lot of benefits to having that. So usually what I tend to do is I'll find a user and I'll go ahead and we won't be able to do it in this video, but I'll make I don't think I can even do it in this folder because I don't have the permissions. Yeah, but I'll go ahead and make an SSH folder and upload SSH keys. We'll probably see that in another box, but because port 22 is not open, remember only port 80 is open, not port 22. So because port 22 is not open, there's really no point in uploading SSH keys just for the simple privilege escalation, because even if I uploaded the SSH keys, I wouldn't, like port 22 isn't open. There's no way for me to SSH to this IP address, so we'll just stay in our reverse shell for now. So in terms of privilege escalations, there's a couple tools that will allow you to auto enumerate a lot of things at once. One of them is linpeas, and there's linpeas and there's some other ones. I tend to use linpeas, but there's also a couple checks that I will just do manually before I run a lot of those auto enumeration softwares, especially for hack the box stuff. So like one of the ones I'll do is I'll try to find any files with SUID bits. Not going to cover it explicitly in this video, but again, you can kind of look up what SUID bits are and how those can be used for privilege escalation. But I kind of have this command memorized now where I do find dash, which means find all files from the root folder. This means find all files with the SUID bit. And this means pipe all errors to dev null, which is a kind of like a special, you could call it a file on your Linux server where it's literally null. You could send any output to it. Like you have it on your Linux server. You can do like echo abc dev null, and nothing happens because dev null is just null. Anything that gets sent there just kind of for the better description just kind of disappears. So this is find all files from the root folder that have the SUID bit and any errors, because this command will sometimes return some errors. Just go ahead and put those in dev null so we don't have to deal with them. I run this and it returns the files. So mount, for example, has the SUID bit. fuser mount has the SUID bit. A lot of these have the SUID bit. A lot of these are pretty standard. In terms of, well, like how do I figure out which ones are standard and which not? There's this website called GTFO bins, and you can put in a binary and it will tell you if it has the SUID bit here, see the SUID tag, if that could be exploitable. So for example, I know for a fact if Vim has the SUID bit, so if I type in Vim, and if you click on that, it'll tell you, if you scroll all the way down to the SUID part, it'll tell you how to leverage that to escalate your privileges. In this case, let's say ping, for example, maybe ping is something we could leverage. I'll go into GTFO bins and I'll put in ping. Doesn't look like it shows up, so there's probably not something I can exploit for SUID. Remember though, this GTFO bins website kind of just catalogs a lot of the common binaries. It doesn't have every binary that could exist on a Linux server. So if someone has like a custom binary, or maybe it's a binary that's, or sorry, I shouldn't say binary. It's if it's a binary that isn't maybe as mainstream, or not as many people use it, or an entry just hasn't been made for GTFO bins, so it's always worth investigating some of them. In this case, I know from experience that a lot of these aren't super applicable and I don't really need to worry about them. So the SUID bit is kind of done. The next thing I'm going to do is I'm going to go ahead and do sudo-l. What this means is this is going to essentially check what this user is allowed to run as sudo. So if I run sudo-l, it gives me back this. It gets this file from a file, or sorry, it gets this info from a file called etc sudoers, which I don't have access to read, but that's where this data is essentially coming from. In terms of sudo, normally on your Kali instance, you're probably used to running sudo some command, like sudo ls, or if you just want to become root, you usually run sudo su. So all this stuff you're doing in the context of root. Just sudo ls means run ls as root. And usually you have to enter your password before it can do that. But sudo is a pretty versatile command in that it's actually, sudo actually means run the command as someone else. And so by default, it'll usually run it as root, but you can totally specify other users. And so if we look at this sudo-l dump, we'll see that it is saying www-data, which is the user we are, which is good, is allowed to run without needing to provide a password all commands as script manager. So remember, normally if we did like sudo ls, it would try running ls as root. And so it would ask us for the password of www-data, which remember we don't have because this is a reverse shell. So let me just click through all the attempts there. Okay, but if we want to run a command as another user, we can use the u flag. So I can do sudo-u script manager ls. Now we're saying run ls not as root, but as the script manager user, which we're allowed to do like we saw from sudo-l. So that one actually returns, and I can even do sudo-u script manager who am I. You can see that the command is running as script manager. If we want to make a shell, right, we probably want a shell to make this easier for us. We can do sudo-u script manager bin bash. This will run bin bash as a script manager, which means if we run this and we run id, we are now in a shell as a script manager. So we've basically pivoted from www-data to script manager. Okay. At this point in time, we now want to kind of take a look in the script manager folder, see if there's anything there we can use. Doesn't look like there's a whole lot in here. I went through some of these files, not a whole lot in here. Always worth checking the bash history, but probably nothing in there. So something we want to find now is, per the name script manager, it probably is managing some scripts, right? That's a pretty good guess. So I want to find any files on the system that are owned by script manager, because if I can find files owned by script manager, there's a good probability that I can edit or manipulate those files because I am the script manager user, and that might give me an avenue to privilege escalate or pivot even further. To do that, you would do let's actually go ahead and check. You can actually ask ChatGPT. So using the find binary, how can I find all files from the root directory owned by a user called script manager? Files or folders. You can use the find command along with the user option. There you go, and it gives it to you right there. So you run sudo. We're not going to use sudo because we're already script manager, but it's find from the root directory. We use the user flag script manager. So we're going to do find -user script manager, pipe all the errors to dev null again. Okay, this gave us a lot of stuff. I wonder if, here we go. Okay, so it gave us a lot of stuff in the proc folders here. I'm not going to go into those. You can also read up on what this proc folder is and stuff, but looking at the first couple of entries that get returned, we can see, okay, we have some files in home script manager, which are owned by script manager, which makes sense, right? Like profile, if we ls.art.profile, right, script manager owns this file. It's listed as the owner. Okay, that makes sense. But we have these first two entries here, which are really interesting. There's a scripts folder, it looks like, and a test.py that are both owned by script manager. So if we go to root, there's our scripts folder. If we go into scripts, we can see we have a test.py folder, or a test.py file, and there's a test.txt document owned by root. So like you can even see, if I try to test, I can cat test.txt, testing 1, 2, 3 exclamation point. But the interesting thing is this text document is owned by root or anyone in the root group. So if we see what is in this Python file opens a file called test.txt and writes testing 1, 2, 3 and closes it. This is owned by us. We can edit this. And the fact that test.txt also exists in this folder and is owned by root means that root is probably running test.py. So it's running these commands, and that's why the output text file is owned by root, because the file is being created by whoever runs the script. So a good idea might be to replace test.py with our own code, because we're the owner script manager, and you can see that the owner has write privileges on the file. So again, to recap, kind of looking at the contents of this file, seeing that test.txt exists and is owned by root tells us that root is probably running this file. And because we are the owner of this file and have write privileges over it, we can edit the contents of this file, which means we can edit whatever root runs. Which means we essentially can have root run whatever commands we want. In terms, like another way to figure out, is root actually running test.py? I use a file called PSPI. And if you search for it, it'll come up here. This is a really handy library, and it will basically list all the running processes in the background, which is really nice if you have like cron jobs or some scheduled stuff running in the background. This is a really nice way to list all of it out. So I'm going to go ahead and just get the, 64-bit. If you run uname-a, it'll tell you it's 64-bit. I'm going to go ahead and download the 64-bit, copy link address, wget, let's download the file here. Okay, PSPY now exists. This is just our local machine, right? This isn't the web server. To get this file onto our web server, we're going to stand up a simple HTTP server on our local host. Then from the vulnerable web server, we're going to reach out to our simple HTTP server and download PSPY. So to run a simple HTTP server, you can actually just use Python again, -m http.server. Port 8080 is already taken from burp, so we'll use 8090. Okay, and we can actually see if you go to like your local host, right? We're running this from our local host. So we're going to have our vulnerable web app or our vulnerable server reach out to this temporary HTTP server that we're running, and it's going to download this file, and that's how we're going to get it on our server. So let's just get our IP address again. We'll use wget HTTP, our IP address, port 8090, PSPY 64. We might not be able to write to this directory because of the permissions, so we'll go ahead do -o and we'll write this output out to the temp folder, because usually anyone can write to the temp folder on a Linux system. PSPY 64. Okay, if we run that, I might have misspelled it. Oh no, that works. This was just me showing localhost. So, but this is the actual log line of when we grabbed it. So we ran wget, it reached out to our web server, and we can see the log here. It grabbed PSPY64 and then it wrote it to temp. So if I ls temp, there is our file. So if I ls rt, or if I go to temp, I need to change the file to be executable, because if you go ahead and list the file by default, you'll see that you have read and write permissions to it, but you have no execute permissions on it, which means if I try to run it, it'll say permission denied, even though I'm the owner and group. So you just have to add that X flag, that execute flag. So you just do changed-mod plus X to PSPY 64. Okay. Whoops. And now if I run that binary again, let's run it. Okay, this is PSPY. So let's see, can I find it? So it will list out a bunch of these processes running in the background. So UID 0 is root. So that's kind of something we want to pay attention to. We can see that it actually is logging some of our reverse shell stuff here. And if we go through the output here, you should see, maybe give it a second. Bin bash I. So it's running cron, right? Like cron is being run. A lot of this other stuff is just kind of noise in the background. I'm not too worried about it. Seems like pretty standard stuff running. But if it shows up, yep, here it is. Okay, so you can see after we waited maybe a few seconds, maybe a minute, that root ran python test.py in the background. And PSPY logged it because it's logging all kind of the processes and stuff running in the background. So this is telling us that root is running test.py periodically, and we know as the script manager user that we can write to the test.py file. So as a script manager, we'll just write another reverse shell connection to test.py, and we'll set up another listener and set up another reverse shell. But this time we'll be setting up the reverse shell as root, because root will be the one running the reverse shell command. So I actually don't know. Can I just quit out of this, or do I have to? Okay. Well, so I had hit Control C to end that. That ends the whole reverse shell connection. Luckily, I can just start the listener again. Go back up here. If you click up, it'll just take the last command. Run it again. Reverse shell's back. sudo-u script manager bin bash. Okay. And then we're in the scripts folder. Okay, so in terms of it's running a Python file, remember we actually already have a reverse shell that works. So we can actually just copy this first reverse shell payload we did. We don't need the Python prefix again because remember root is just running Python already on the file. So I'm going to go ahead and copy this. Come over here. Going to first remove test.py. If you want to be more sneaky, you could try appending Python commands to the end of test.py. I'm just going to go ahead and remove it. I'm going to go ahead and make a new file. See if this works. Hopefully. Yeah, I have to change that port, right? So like this all works. The only change would be the port, because we need a new port for our reverse connection because we're already using port 8989. So let's go ahead and set up the listener. So let's do 9999. So we need to change this to 9999. Let me go ahead and do that real quick. Oh, actually. Okay, let me go ahead and do that real quick. Oh, yeah, sometimes Terminator has some problems with like multi-line stuff. There it goes. Okay, and then 9999. Sweet. Oh, but this is going to cause problems, right? Because we're echoing and we're using a quote, and then our payload has a quote in it. So ideally, this should probably be a single quote, so it doesn't break our outermost outer quote that we're using for echo. You know what? Let's just make this simple. I'm just going to go ahead and make the file locally, and then we can just use wget again to just grab the file like we did with PSPY. Okay, yeah, so we're just going to go ahead and make it locally. So I'm just going to, let's cancel that listener for a second. It's called test.py, right? Yeah, test.py. Oops. There we go. And the port we're going to choose is, oh. Try that again. Copy this whole thing. Remember, we don't need that Python prefix because it's already just running Python and the file. So just Python commands, and we're changing this port to 9999. Save that. We already have our simple HTTP server running, right? If we refresh this, we'll see now we have test.py in there. Let's move that to our vulnerable server. So wget HTTP 8090 test.py. We're writing it to this folder, right? Because this is where root is running it. Test.py. Let's go ahead and set up our listener so it's just sitting there waiting for the connection. Okay, great. We now have test.py in there, and so again, it's probably on a schedule, and so we should see maybe in a minute or so, root will automatically run test.py, and test.py has a payload that will execute a reverse shell to 9999, and we have a listener waiting on our localhost for 9999. So we just have to wait a minute or two. Yep. So after a couple seconds, we get a reverse connection. So root ran test.py, which means it ran this Python code, which executed a reverse shell, which reached out to our local host, or our local machine, and we had port 9999 waiting and listening. So if I run who am I, we are now root. So we basically start as the www-data user. We use sudo-l to become script manager, and then we edited some code that root was periodically running to make another reverse shell, and because root was running that code, it made the reverse shell as root. And now we're root. We have pretty much access to everything per root. So if I go cd root, bash-i, yep, you can see we have root.txt, whoops, cat root.txt. And I can go over here and I can submit that flag. This should work. This might just be hack the box. There it goes. Okay, so just had to refresh the page. And so that pretty much concludes it. Again, it's usually good to just Google. So this was called bash. So like bashed walkthrough. So you can see this is retired, right? So it's totally fine to do a write-up on retired boxes. So like we can look up a write-up really quick and see exactly what they did. Right? It looks like they used the Python reverse shell too. They actually used port 99992. Yep, and test.py, and then pretty much did the exact same thing here, but you can see there's tons of write-ups, so some people have kind of different ways of going about doing it, and that should pretty much be it. Yep, so that's it for this box. Let me know if you have any questions during the class time, or if you have any questions about this box specifically. But for now, I think that concludes this video.